All right, we got our quizzes review. We're going to get started. My name is I Win, and I dare you to do better than me. Question 1, solve for x. 4 times 2 to the 2x power minus 3 equals 60. We're going to do 4 times 2 to the 2x. We're going to add 3 to 60. So we're going to say equals 63. Then we're going to divide by 4. So we're going to have 2 to the 2x equals 63 divided by 4. That is 15.75. Then we're going to do a log. Base 2 of 15.75. We're going to say equals 2x. Log, shift minus 2, parentheses, 15.75, close parentheses, 3.97727. Equals 2x. Then divide by 2. X is going to be that number divided by 2, which is 3.97727999235 divided by 2, 1.9886. Well, that rounds, my friends, to 1.989. 1.989. So that's going to be your answer. Something close to that. Let's submit it. Got it. Number 2, solve 13 to the 2x equals 84, round to 4 decimal places. 13 to the 2x equals 84, round to 4 decimal places. Let me offer you a different way to do this. So we could say logarithms are our thing, but we could also do a graph. So we would do 13 raised to the 2x power. And down here you would say y equals 84. And you're going to have to drag your graph down because we need to see 84. And those intersect at 0.864. 0.864. Let's see if that gets us the right answer. We can also use logarithms to do this, but you can look at my previous example for that method. Oh, it says it's incorrect. That's because I rounded incorrectly. It should be 0.8637. No worries. Canvas test will allow for rounding errors, like myself included. Next question. Let's do this one doing logarithms. So we have, as we're going to annotate here. Oh, what is my? Let's do red. So we're going to do over here. Come on, let me draw. My bad. So we're going to do a logarithm this time. We're going to say log. What? That is too thick. Log. There we go. Base 5 of 2137 is equal to 2x minus 6. So we're going to do all of that here, and then we're going to evaluate log base 5 of 2137. So log, shift minus 5, right arrow, parentheses, 2137, close it up, 4.763873. $4.763873 equals 2x minus 6. Add 6 to both sides, and you're going to get 10.763873. And then you're going to divide by 2. So I will do that work in the calculator. So we're going to take that number, 4.763873 plus 6. Then we're going to take that number, 10.763873, and we're going to divide by 2. And that gets us 5.38. Oh, good. Next question. Okay, what is the solution to the equation 4e to the 8x equals 20? For e to the 8x equals 20. All right, to solve this problem, we are going to use the natural logarithm. So let's go. We got 4 times e to the 8x power equals 20 divided by 4. That's going to be 20 divided by 4 is 5. So e to the 8x equals 5. When you have e to a power, that log is the natural log. Log base e, ln. Put the 5 in there. It's implied the base is e, so you don't really need that. Equals 8x. So it's going to be ln of 5 over 8 is equal to x. Boom. We can check our answer in the graph. If you would like, you can say ln of 5 divided by 8. And we can say 4e raised to the 8 times, oops, use parentheses, 8 times 0.201179739. As you can see, that's going to give you about 20, which is the answer. So yes, got it. Next question, solve the following equation. Log x minus 3 minus 2 log 5 equals log 1/2. Now, I did not include videos going over these log equations. So what we're going to do is let me show you a couple tricks. Anytime you have a coefficient out front, move it to the power in here. So that's going to be a second power. So we're going to write that as log x minus 3 minus log 5 squared equals log 1/2. 5 squared, of course, is 25. So this minus, anytime you have a minus that you're subtracting logs, you write it as 1 log and divide the two things in here. So we're going to write that as log, big parentheses, x minus 3 divided by this 25. And we're going to set it equal to the log of 1/2. Now, what happens when you have a log on both sides? That they have the same base, they're going to cancel out. And so your equation becomes 25, or excuse me, x minus 3 over 25 is equal to 1/2 or 0.5. So if you multiply the 25 times the 0.5, half of 25 should be 12.5. We can check that in here if you'd like. 25 times 1 divided by 2 is 12.5. And then you're going to add the 3 to that. And so you'll get 15.5 as evidenced by my calculator work here. So you're going to get 15.5. And you might be asking yourself, do I want to do this using a graph? Why not? So we could do log, parentheses, x minus 3 minus 2 log, well, I'll just put the 5 since there's no parentheses, doesn't matter. You could say log, parentheses, 1 divided by 2. Now over here, you're going to want to say y equals. And I'm going to go back, hit the home button here, and let's see if I can find them intersecting at 15.5. And it sure does. 15.5 is your answer. So let's check that here, submit it. Heck yes, heck yes. Next question. Oh, I get a power up. Check me out. Come on, come on. Let's roll the dice. Let's get this done. Another log question. Right? All right. What's going to happen here? Well, I got it. I don't need to know. Okay. 2 log 2 base 2 of x plus log base 2 of 5 equals 2. All right. The product property states that when you have 2 logs after you've taken care of your exponent, so log base 2 of x squared plus log base 2 of 5 equals 2. So when you have 2 logs that have the same base being added together, we can combine them into a product. So log base 2, we're going to say multiply these two together. So 5x squared. We set that equal to the right side. Now this does not have a log to cancel out, so we're going to rewrite this as an exponential. We would say 2 to the second power. We always start with your base, raise it to that power, and we set it equal to what's inside the logarithm, so 5x squared. So 4 equals 5x squared. Let me transfer that over here. 4 equals 5x squared. We want to divide by 5. 4 divided by 5 is 4/5 or 0.8. Then we will square root 0.8 to get x. That should give you the square root SQRT of 0.8, 0.894. So 0.894. Whew, got it right. Next question. A population has 25,000. If it grows by 7.4% per year, about how many years will it take to reach 60,000? 60,000. Let's do it. So we got 25,000 people or insects. I don't know. It doesn't say what it is. It grows. So that's going to be 1 plus r. Your rate is 0.074. Always move that decimal 2 places to the left. Put a 0 as a placeholder if you need to. So it's going to be 1 plus 0.074. So that's 1.074 raised to the, well, we don't know. So we'll call it x. And we set it equal to 60,000. So we can divide. And 60,000 divided by 25,000 is going to be about 2.4. Let's see, 60,000 divided by 25,000, 2.4. So we have 1.074 to the x power equals 2.4. 1.074 to the x power equals 2.4. Now we're ready for logs. So we say log base 1.074 of 2.4 equals your exponent. So let's put that in the calculator. Remember, you can also do logs by change of base. So you could do log without the base by doing log 2.4 divided by log 1.074. So that is an option 2. And of course, remember, you can just do log shift 1.074, right arrow 2.4. Same deal, you get 12.26, 12.26 rounds to 12.3. You can also do a graph intersection, which I'm not going to do at this time. All right, next question. The population of bacteria grows according to the function P of t equals P of O times 1.38 to the t power, where t is measured in hours. If the initial population size was 3.000 cells, we're going to change that to 3,000 because that is a typo. 3,000. Approximately how long will it take the population to exceed 18,000? So we're going to start with 3,000. That's your PO box. 1.38 to the t power equals 18,000. All right, let's divide. Actually, I'm going to use a graph. You can use logs or a graph. So let's use a graph. Do something, change it up a little bit. So 3,000 parentheses 1.38 raised to the t power. I'll just call it x because you can't put t in Desmos. And then you say y equals a whopping 18,000. Now, you know you can't see 18,000, so you got to move it. You got to move it. So let's zoom out. Click that a lot because 18,000 is way up there. Now, I'm going to zoom that in. I want to see where they cross. So let's see. 5.563. It says 2 decimal places. So 5.56 would be appropriate in this case. 5.56 should be your answer. You can double check that. 3,000 parentheses 1.38 close parentheses, raise it to the 5.56, and you're going to get pretty close to 18,000, 17,982. So let's submit it. You can also use logarithms to do that as well. So you got methods, you got different ways to do these. And I don't care how you do it. Oh, this is a redemption question. Remember how I got this wrong because I didn't round it correctly? So this is going to be, let's do it as a log. It's going to be log base 13 of 84. And that's going to be 1.727 44806. And we're going to divide that by 2. And we should have 0.8637. And I had rounded that to 0.864, and it did not count that right. But now we're good. All right, so now I got them all right so far. I win is in the lead. All right, the Smiths bought an apartment for $80,000, assuming that the value of the apartment will appreciate at a continuous rate of 3.7%. How much will the apartment be worth in 11 years? Continuous interest, my friends. A equals P e to the RT power. So if it's continuous, you got to have that power. So we're going to say $80,000 times E. The rate is 0.037. So 0.037 in the exponent times, what's the time? 11 years. So times 11. So that's a calculator part at this point. So let's plug that into here. 80000 E exponent 0.037. Put that in parentheses. Multiplied, shift 8 times 11. That apartment is going to be worth $120,184.32. Whole dollar would just be 120,184. Yes, we got it. All right, next question. Ooh, I got a power up. Man, I'm just on fire, on fire. I win is in the lead, as he should be because he made this. You have a car currently worth $18,000 that is depreciating at a rate of 13% per year. What will the car be worth in 7 years? Round to the nearest dollar. Depreciating means decay, going down. 1 minus the rate. What's it going to be worth in 7 years? So 18,000. 1 minus 0.13. That's your exponent. Your time is always going to be your exponent. We want to know what's it going to be after 7 years. So it's going to be 18,000. That's going to be 0.87 to the 7th power. That's a calculator problem. 18000 parentheses 0.87. Shift 6, 7. So 6790. 6790.58. We'll round to 6791. You can lose money on those cars. Don't buy new. That's your pro tip for the day. All right, next question. A ring you purchased for $2,000 is appreciating. And it doesn't mean you really like it. And I think that's a really nice thing. It means it's increasing in value. So in the sense, I guess things that are appreciating should be things that are liked, right? So that's going to be appreciating. That's 1 plus R. That's growth. By 2.5% a year. What's it going to be worth in 20 years? $2,000. 1 plus 0.025 raised to the 20th power. So $2,000, 1.025 to the 20th power. Back to the calculator. 2000 parentheses 1.025 close parentheses shift 6 20 327723. This thing's going to be worth $3,277 in 20 years, assuming you take care of it. Number 12. Let's go. Let's go. Look at all these people playing. All right, you invest $800 into an account that accrues 5% interest compounded quarterly. By which equation could this be modeled by? Accrues is grow. Compounded quarterly. The formula for compound interest is A equals P, parentheses 1 plus R over N to the NT power, where N is the number of times per year it's compounded. If you're quarterly compounding, N would be 4. Your rate is 5%, 0.05. So what you're going to have in here is $800 times 1 plus 0.05 over 4 to the 4n power. So obviously our number in the parentheses is not broken up, so we have to figure out what 1 plus 0.05 divided by 4 equals. And of course you get 1.0125, but you got a 4, I put an N there, that should be a T. So you got a 4T up there. That doesn't matter what you call your variable. Typically they're called T, but in this problem they're called X, right? So it's gonna be this one because you have the 1.0125, but you also have the 4 with the compounded part. So it's gonna be that last option, letter D. Let's get it done. Let's select it. Let's see what we have. There we go, moving on, next question. I win is in a commanding lead. Can you get better? Can you get better? Maybe if you go through this after doing it and remember the answers, you can. The value of a computer is modeled by 925 times 0.51 to the T power, where T is the number of years since the computer was purchased. Which function best represents the value of the computer in months? It's all about that number, guys. Take your 0.51, raise it to the 1/12th power. That'll get your rate broken down into months. So 0.51, if it's in the equation, it's as simple as taking what's in the parentheses, 0.51, raising it to the exponent 1 divided by 12. Then your base becomes something closer to 1. So in this case, 0.51 is going to get closer to 1. It'll be a little bit higher, 0.945. So your new your new function is going to be your same starting value, 925, but then it's going to have this number in here, 0.945, 4, etc., to the m power, where m is the number of months. So it's going to be this one. It's still decay, so it's not going to have a 1 in front of it. All right, number 13. We have 4 more, number 14, we have 3 more to go. Faith opened up a savings account with a 7.2% annual interest rate. Which choice best represents her monthly interest rate? So again, this is kind of similar to the last one. We have, except we don't have a starting amount, right? So we have some starting value, which we don't know, we don't care about. But we have 1 plus your rate. To the years. So the monthly rate is going to be 1.072 to the 1/12th power, and that'll convert that, so it'll be P times whatever that number is to the month's power. So let's figure out what 1.072 to the 1/12th power equals. 1.072 raised to the 1 divided by 12, and you get 1.0058. 1.0058. And then you're like, well, I don't have that. What the heck? Guys, it says, what choice best represents her monthly interest rate? This is just the base. It's not the rate. It's got a hidden rate in it, right? So you have this 1.0058, and then you're like, well, where's the rate? Remember, 1 plus 0.00581, that's your rate right there, but that's your rate as a decimal. So the rate as a percentage is going to take that decimal and squeeze it over here to the right between the 0 and the 5. So it'll be 0.581%. 0.581 if you want to put a 0 in front of it, but it's going to be that one. Very, very small. Nice, very nice. If you know what reference that is. All right, next question. Let's see how we're doing. All right, we have 2 more, 15 and 16. Let's get it. What's the inverse of 4 to the x power? Inverses of exponentials are logs, but I got a few logs. Which one is correct? 4 to the x power. Log base 4 of x. It's as simple as that. You put the base in the log and the x is part of your log as opposed to the exponent. You see how those are nicely reflected over the line y equals x? Boom, that's how you know they're inverses. So it's going to be this one. And one more. What's the correct logarithmic form? This one's kind of a gimme, hopefully. But the correct logarithmic form of this is going to be log base 3. That's your base. And then you go to the other side. That goes in your parentheses. And then you set it equal, always equal to your exponent over here. So it should be log base 3 of 18 over 81 equals -4. And of course, my thing's a little wonky, but it should be that one there. Well, I did really well, but then again, I hope you would expect me to do well. Now you can go through this, try these on your own, redo it. Try not watching my video. I'd like to see if you can do this, again, remembering what we talked about in the lessons and even in this video if you watched it. And then do it again and then watch the video again if you need to. Play it as many times as you want. I don't care. Review for that test. Do well on that test. Love you guys. We'll see you later.